Hi everybody. So this is day 3 of similar and congruent triangles, and you want to write the title in your notes, real world applications, and then go ahead and put the date. So go ahead and pause the video if needed and write that down. So what we're looking at here are some examples of triangles in the real world. This first example you can see supports of this swing set. You've got these congruent triangles here and here and here and here, and they form the support of that swing set. If you look at this bridge, you'll see that what you have is a progression of triangles, and as you move farther into the water here, this bridge gets higher and higher up, so those would show you an example of similar triangles. Same shape, but noticeably a different size. They get increasingly bigger as you go towards the middle of the bridge, and then increasingly smaller as you go towards the end of the bridge. Here's another example of two congruent triangles, and if you look at them, there's actually two sets. You could look at the smaller triangles here with the support, and then you've got the larger triangle, and these would be considered congruent. Same size, same shape. So we have kind of a simple geometry problem here, and I do want you to write this one in your notes. So go ahead and pause the video, copy down example 1, and then write out the scenario and then draw the picture. So what you have here, so again, don't forget to pause the video, write down the description, and then draw out the picture. So sketch yourself a little picture here. So go ahead and pause now. So you have two things happening here. You have Joey who's standing here by this tree, and what we're trying to figure out is what is the length of the shadow of the tree. So if you're standing and you have like the sun on you, so let's say that the sun is, if the shadow is going this way, then that means our sun is probably over here. So you don't have to draw the sun, but you can if you want. So I'm going to draw out the sun. Okay, so let's say that this is the sun here. And then that would make the shadow go in this direction. Now, that's not really that important, but I just want you to see kind of what we're looking at. So the shadow is going one direction or the other. It doesn't matter which way you put the shadow as long as you make the shadow the same in both diagrams. Okay, now what we know is that these are similar triangles, and when you're talking about a tree or somebody standing, you can assume that it is going to be perpendicular to the ground. So right here I have my 90-degree right triangles, and so what I have then is a proportion that I can set up. Let's start with the missing side, the tree. The tree matches up with the height of Joey. The next thing I'm going to do is I'm going to look for the side that would represent the shadow. Now in the tree, that side is the side that's 38 feet. And that matches up with Joey's shadow, which is 42 inches. Now, some of you may well, wait, do I need to convert these things? No, here's why. So this was 63 inches. His height was his shadow was 42 inches, and this is feet. When we get these answers, what will happen is that these two numbers at the bottom, which represented Joey's height and his shadow, are going to match up with the feet of the tree and then the tree here as well. So if this was feet and it asked for your answer in inches, then you need to be worried about converting. But since Joey's measurements are both in inches and the tree is both going to give you measurements in feet, then we don't have to worry about changing anything from inches to feet or anything. Okay, so but what we do need to do is go ahead and cross multiply. Okay, so I'm going to go to my calculator and type this. So 42 times x is just 42x. And then 38 times 63, I got 2,394. I'm going to go ahead and divide by 42. And I got x equals 57. So let's at least consider the unit here. This was feet. We were finding feet. So let's just kind of check to see if that answer seems reasonable. If the shadow was 38 feet, then does it seem reasonable for the tree to be 57? Well, Joey's shadow was 42 inches and he was 63 inches, which is a greater amount. So then 38 and 57, that seems reasonable. So that would be your answer. Similar triangles. Okay, here's our second example, and you could just call this example B if you'd like. It's actually question 12 from your book, and you're going to copy it down. So go ahead and pause the video, copy down this example. It's example 12 from the book. You can just call it letter B, but copy down the word. So pause the video now. So I'm going to start by sketching a diagram of the scenario. A vertical pole, remember vertical means you're going up and down. A vertical pole that's 30 feet tall casts a shadow that's 8 feet long. So I'm going to start by drawing a vertical pole. Maybe it's a flag pole, maybe it's a telephone pole, it doesn't say, but what we do know is that it's 30 feet. It's going to cast a shadow, according to this, that's 8 feet long. It doesn't matter which way you draw the shadow. If you put the sun back here, then you're going to draw the shadow to the right. If you put the sun on the other side, it doesn't really matter. Again, the idea is that you're just thinking of putting the shadow in the same direction. So I'm going to put my sun here. That means my shadow will go to the right. And as you can see, it's not drawn to scale because it says my shadow is 8 feet. This is not the same length, 30 and 8. It's not drawn to scale. It's just approximate. How long would the shadow of a 40-foot pole be at the same time and place? How long would the shadow of a 40-foot pole? Okay, let's draw a 40-foot pole, so a little bit longer than this 30-foot one. Again, these are not drawn to scale. And then we're looking for how long will its shadow be? So this one was a 40-foot pole, and we're looking for how long will its shadow be? So that's what we're trying to figure out. Well, what you really have here are really just two triangles. And when you have something vertical to the ground or standing on the ground, you can assume that these are 90-degree right angles. So when something is standing up in relation to the ground, you can assume that it's going to make that right angle with the ground. All right, well, let's solve it. We're trying to figure out the length of the shadow. Now, you know I'm visual, so I'm going to go ahead and put some little squiggle marks on the corresponding sides. So X is going to match with side 8. Okay, now also, let's see what else we know. We know that this side, so if I started with X and then I went to 8, then I should go back to 40 and pair that up with 30. Okay, let's cross multiply. So you've got the 30x is 3,200. 4 times 8 is 32, and you just add a 0. Oh, it's not 3,200, it's 320. Too many zeros there. 4 times 8 is 32, add a 0. Okay, now what I'm going to do is I'm going to solve it the rest of the way. Divide by 30. Need my calculator for this one. So 320 divided by 30. And I got 10.6 repeating. And it kind of keeps going on and on. Now, what I can do is I can round this. It doesn't specifically tell you where to round in the directions, so I can round it to 11. I could round it to 10.7. If the directions tell you, follow the directions. Otherwise, you can go ahead and just round it to 11 feet. So if you put 10.7, that's not wrong unless it specifically tells you where to round. So you can also round it up to 11 feet. So again, read the directions, and if it doesn't tell you to round, you can round to the nearest whole number or to the 10th place, your choice. All right, so this is the type of questions you're going to be working on for this unit. Go ahead and write the assignment down, and then I want to do one of the questions with you. So go ahead and pause the video and write down the assignment. Okay, so I'm going to take a look at question 62 with you. And the reason I have Mount Rushmore snipped here is because 62 talks about Mount Rushmore, and it also talks about the dimensions of the face of one of the carvings, and then what would that be in real life. So I'm going to read to you question 62. I'm going to help you set it up, and solve it. Assuming that Lincoln was 6 1/3 feet tall and his head was 3/4 of a foot long, knowing that the carved head of Lincoln at Mount Rushmore is 60 feet tall, find how tall his entire body would be if it were carved into the mountain. So what they're saying is if this carving of Lincoln was actually a full-size carving of his body, how big would that carving be based on this scale of Lincoln? All right, so this is question 62. And again, it's part of this assignment. So I added the information that was given in the book. It was given that his height in actual real life was 6 1/3 feet high. That's his height, how tall he is. His face was 3/4 of a foot. And this carving here from top to bottom is 60 feet high. So again, the question is, what would then be his height in a carving? So this would be the carved height is what we're looking for. So what I can do is I can set up a proportion of this information. So I'm trying to find his carved height. Like if I was to have a full carving of his whole entire body, his carved height will be my X. And I'm going to match that up with his actual height in real life, which is 6 1/3. So next, what I did was I put his the length of his face at the top here. Again, this was, okay, sorry, I had those two switched around for a second. I realized it as soon as I started saying it. So if this is the height that we're trying to figure out of what the entire carving would be, this is his height in real life. If this is the face of the carving and this is his face in real life, then what would the height of the carving be? So again, this is real life height. This is real life face length. This is carving height. This is carving face length. Let's cross multiply. Okay, so I'm going to go ahead and cross multiply what I have. 3/4 times X is just 3/4 X. And 60 times 6 1/3. All right, so this is where you're going to have a little maybe confusion. But what I did was I took this 1/3 and I went ahead and I divided it in the calculator. So 1 divided by 3 is just 0.3 repeating. So instead of typing in 6 1/3, I just typed in 6.333 repeating into my calculator. Okay, so I typed in 60 times 6.333333. I just put a whole bunch of them in there and I got 380. So I got 380. The next thing I want to do is I want to get rid of this 4. So you have two options. You can multiply both sides of this equation by 4/3, or you can just kind of take it one step at a time. I'm going to go ahead and multiply both sides by 4 just to get rid of that fraction. So again, there's two different ways you could do this. You could multiply by the reciprocal and just do it all in one step, or you can get rid of the 4 to start out. And I got 1520 first when I multiplied 380 times 4. I'm dividing by 3, and I get 506.6 repeating, which I went ahead and rounded to 507 feet. So if they were to carve Lincoln with the same proportions as what you see in Mount Rushmore, which is in South Dakota, then he would be 507 feet tall. All right, so here's a kitty Mount Rushmore. I think it's pretty cute. Okay, so I'm going to show you one more time. These are the questions for this section. You'll also notice that not only are you doing these real-world problems, but you're also going to be a page that includes review. It's called the quiz. It's not a quiz. It will be a practice of all of the material that we have been working on so far. All right, bye for now.